Bismillahirrahmanirrahim. I am Professor Jamil. You are watching my YouTube channel. Today we have lecture number 3 on gamma function, and this lecture, which is in fact a video lecture of short duration, and I call it as a lecture, mean video lecture. So this is lecture number 3, and it will consist of rather on solving a problem, because there is no substitute of understanding physics except solving the problems. Not only for physics, in fact, science comes to you in its most real and practical form when you solve the problems. So, on gamma function, let's have a problem. And this problem is also an exam question as well. So, statement of the problem is evaluate x plus 4 factorial, this is factorial sign, for whatever x. X could be any mathematical object. Whatever this mathematical object is, you need to evaluate x plus 4 factorial, right, by using fundamental recurrence relation for gamma function. Also, this is other part of this question, also generalize your result to x plus n factorial for positive integer n. N is positive integer, then what is x plus n factorial? And you will develop its formula by generalizing the result which you obtain for x plus 4 factorial. And in x plus 4 factorial, you have been told how can you prove it? You can prove it by using fundamental recurrence relation for the gamma function. Fundamental recurrence relation for the gamma function has been derived in my lecture number 2. In fact, it's lecture number 2, video lecture number 2. And for its proof, you can first go into the details from lecture number 2. And if you already know it, then let's solve this problem. So let's solve it on the board. Solution. And solution is about what? In the first part, we need to evaluate x plus 4 factorial is equal to what? And for this, we need to use fundamental recurrence relation. Let's write it. The fundamental recurrence relation, RR for recurrence relation, for gamma function is, let's write it, gamma of z plus 1 is equal to z gamma z. You can name it as equation number 1. And also in lecture number 2 on gamma function, mean vector number 2 on gamma function, gamma z plus 1 has also been proved to be equal to z factorial also. So you should write that as gamma z plus 1 equals z factorial. Why we have written this down on the board? Because we are asked to find factorial through the gamma function, and factorial through the gamma function is related with this equation. and this relation has been written because it was asked to be used in the statement. So by writing these two, now we move into our problem. We need x plus 4 factorial. How can we achieve it? Remember, these relations are valid whether x is a real number or whether z is a real number or z is a complex number, right? So we can use these relations. For a factorial of x plus 4, we can use this relation. What should be z? So that you have x plus 4 here. So x plus 4 factorial mean z should be x plus 4. So in this equation, replace z by x plus 4, which would mean that x should be some real number or some complex number, right? This was not reported in the question, but our relations on gamma functions are indicating that z is a real number or complex number. So let's first replace. So replace z by x plus 4 in equation number 2. So it will give you x plus 4 factorial, which you are required to find out, and on the left you will have gamma of x plus 5, because x plus 4 plus 1 will make x plus 5. Now x plus 4 factorial is equal to x plus 5. Here is where you will use this reckoner relation. This is like gamma z plus 1 is equal to z into gamma z. Argument of the gamma function on left has been decreased by 1, and argument of the gamma function has been decreased by 1. So by using this relation, using equation 1 on left hand side, so what will be gamma x plus 5? X plus 5. Remember, have a very careful look here. You need x plus 5. Imagine this is x plus 5, and here will be x plus 4 into gamma x plus 4. Argument, whatever argument is, it is reduced by 1 here and it is reduced by 1 here, right? So when you use equation number 1, so gamma x plus 5 is equal to, this is, imagine x plus 5, whole x plus 5. Then this is x plus 4 and this is also x plus 4. So this is x plus 4 into gamma x plus 4. And this one is same, x plus 4 factorial. Now you have gamma x plus 4. And use this equation number 1 again. Using equation number 1 for z plus 1 equal, look, z plus 1 is equal to x plus 4. That means z is equal to x plus 3. So in equation number 1, you will use x plus 3. So x plus 4 into gamma. This is x plus 4, and here you have x plus 3 x plus 3 into gamma of x plus 3 and x plus 4 factorial here. Now you have x plus 3, and again use relation over here. Once again using equation number 1 for z plus 1 on the left, z plus 1. This z plus 1 is x plus 3, and it means z is to be replaced with x plus 2. So do this. X plus 4 into x plus 3, and now this gamma x plus 3. here, and x is to be replaced with x plus 2. So it will be x plus 2 into gamma of x plus 2, and right hand side is same again, x plus 4 factorial. Now you have x plus 2, and use this relation once more using equation 1 once more. For now this is gamma z plus 1 and you have gamma x plus 2, mean x plus 2 is equal to z plus 1. So x plus 2 equals z plus 1. That means z is equal to x plus 1. So z is to be replaced with this x plus 4, like this, then x plus 3, x plus 2, and this gamma x plus 2 here is equal to, z is to be replaced with x plus 1. So it is x plus 1 and into gamma of x plus 1, and you have x plus 4 factorial. Now you are left with gamma x plus 1, and from equation number 2, x is z. When x is z, then it is x plus 1 and this is equal to x factorial. So using equation number 2 for z equal x, because when z is equal to x, gamma x plus 1, here z is equal to x means gamma x plus 1. So this gamma x plus 1 is equal to x factorial. So using equation number 2 for z equal to x, you have x plus 4 into x plus 3 into x plus 2 into x plus 1 into this one is x factorial. So it is equal to x plus 4 factorial. Or you can write it as x plus 4 factorial is equal to x plus 4, 3, 2, 1 and x factorial. This is your result for x, where x is any real or complex number, because the relation in equation number 1 and equation number 2, they are valid for real real number z or for complex number z, and this relation is here again x factorial. Look, this is z factorial. So this is valid for z whether real number or it is a complex number. So when you take factorial of this x plus 4, 4 is an integer. What should be x? X should be real number or complex number. So where x is any real or complex number. This is your answer number 1. Now, in the second part of the question, this is the question. This is the second part. You have to generalize your question, your result for x plus 4 factorial to x plus n factorial, and n is integer, positive integer. So let's check how can we go to generalization. This is x plus 4 factorial and you start from x plus 4 and reduce 1 each time for the next factor and go up to 1, and in the end you have x factorial. Similarly, so on generalizing above boxed equation as a boxed equation, and for example if it is x plus 5 factorial, it will be x plus 5, then each time you will reduce the number by 1. So it is x plus 4 and x plus 3, x plus 2, x plus 1. So you will keep on reducing the number by 1 until you reach 1. and in the end you should use x factorial. And for the case if the digit 6, 5, 4 or 5 is n, then the generalization should be obvious now. Similarly, your x plus n, it will be x plus n factorial will be what? It will be x plus n into x plus n minus 1 into x plus n minus 2 dot dot into x plus 3. If n is an integer, then it keeps on reducing and it reduces up to 1. From 5 it reduces up to 1. And here it will reduce up to 1. So x plus 3, x plus 2, x plus 1. And in the end you have x factorial. So this is the general result for x plus n factorial, and x, whatever x that was given in the statement, that whatever x is not arbitrary, it can be any real number or it can be any complex number. For example, if there was a matrix and you need to calculate its factorial, so there is no method for calculating factorial of a matrix for the time being. Maybe in some future we will be able to find factorial of a matrix, but so far as we know to date that we can find factorial through the gamma function only for the arguments which are real number or complex number. Mean x plus 4, x plus n should be a real number or a complex number. So where you should report x will be a real number or a complex number. This is the sign of explanation. Your question according to the statement has been done, and this is the end of your problem. Thanks for watching. Keep watching my YouTube channel for more interesting videos on gamma function, because these lectures are video lectures, are vectors as I say, will be important for your examination point of view in various universities of Pakistan and across the globe. Thanks once again.